Hello, in this video I will show you how to install and get started with the SDL3 library on Windows using Visual Studio and vcpkg. In the first part of the video I will show you how to install Visual Studio with C and C++ support. In the second part I will show you how to install vcpkg. Once we have vcpkg we can install SDL3. Third and last part of the video will be a simple introduction to SDL3, how to create an SDL3 window and renderer, how to fill the screen with a solid color, and how to draw a circle made by points. Feel free to skip the parts that are not relevant to you. For example, if you already have Visual Studio installed, skip to the next part of the video. Software evolves and things that worked at the time of this recording may not work in a few months or in a few years. Please check the video description for updates and corrections. That being said, let's get started. Open your browser and search for Visual Studio. I will use the free Community Edition. Once the download has finished, start the installer. Make sure to select the Desktop Development with C++ workload. This will ensure that the C and C++ compiler are installed and ready to be used. Once the installation has finished, restart your Windows machine as recommended. Next, we need Git for Windows. You can keep the default settings as suggested by the installer. Open the Windows terminal and create a working folder. In my case, I will create a folder named Work on my C drive and CD into it. Use your browser to navigate to the GitHub vcpkg page. Scroll down to the Get Started and click on vcpkg with MS Build. This is the easiest approach on Windows. Next, we'll clone the vcpkg repository as directed. CD into the vcpkg directory and run the bootstrap script. In order to make our life easier, we'll run vcpkg integrate install. This will ensure that any library installed with vcpkg is available inside Visual Studio without any manual settings required. Visual Studio will take care of linking the proper libraries to our code based on what is required. Let's search what packages are SDL3 related. Use vcpkg search SDL3. Now, let's install the SDL3 library for Windows 64 bits. At this point, you have SDL3 installed and ready to be used from Visual Studio. Another useful library is SDL3 Image. This will let you load or save PNG, JPEG and other image formats. Without SDL3 Image, you will be able to use only BMP images with SDL, unless you install another image library, of course. In order to install SDL3 Image, first let's check what is available. Let's install the library with support for JPEG, PNG, TIFF and WebP image formats. Next, let's fire up Visual Studio, create a new project and see some SDL3 in action. Choose Empty Project. Give it a name and make sure Play Solution and Project in the same directory is checked. At this point, we have an empty project. Right-click on Source Files and add a new C file. I will call this main.c. As a side note, you can as well use C++. I prefer to use C for this video for simplicity. SDL3 has introduced a new optional way to structure your app. The new way is using callbacks. These are predefined functions that SDL3 will call for us. This simplifies our life because we don't need to write ourselves the application loop, and it will also make our code easily portable to other platforms like Android, iOS or the web. For this video, I will use the new SDL3 callback functions. Start by including the required headers. In order to enable the callback interface, we need to define SDL main use callbacks. The first callback function required by SDL3 is SDL AppInit. This function is called only once at the start of your application. It is meant to be used for anything that needs to be initialized at the start of your program. Second callback is SDL AppIterate. This is where your application state will be updated and rendered on screen. This function is called every time the system is ready to show something on screen. The third callback is SDL AppEvent, which is called every time an event happens, like for example when the user presses a key, touches the screen or when the application is closed. Fourth and final callback is called once when your application is ready to exit. Here you can, for example, clean up the resources you've used. Let's build our program to see if everything is in order. Oops, I have a typo. I've put a dot instead of a comma. Let's fix it. Now the program will build, but with warnings. Let's deal with these warnings. If all is well, as in no error was encountered, the first three SDL callbacks should return SDL app continue. Now, SDL needs to know what subsystems we need. For this getting started video, all we need is the video subsystem. Be aware that there are more systems that you can enable based on your needs, like for example the camera subsystem, which will let you access any attached webcam. The camera subsystem is something new in SDL3, and I will make a separate video that shows how to use it in the future. For now, we'll assume for simplicity that all requests to initialize something will succeed, so we won't check for errors. We'll fix this later in the video. Once the video subsystem is on, we need a window and a renderer to be able to draw anything. Again, for simplicity, we'll initially use global variables. That we'll fix later, once we see that our application works. I will use a window of 800 by 600, but feel free to modify these numbers if you want a larger or smaller window. Next, we will initialize the window and renderer. Again, we assume that all goes well and we don't check for errors. Please note that on SDL3 you don't need to free or destroy the window and renderer at the end of your program. SDL3 will release these two for you. Next, let's fill the app event callback. For our purposes, we'll only deal with the event of app quit. Basically, when you close the app window, this event will be triggered. If we return SDL app success, SDL will leave the app loop and go into app quit. Now, let's go to the app iterate and draw something. We can define the render color. In this case, I picked a bluish solid color. When we call the render clear function, the window will be filled with the previously defined render color. Finally, we use the render present function to update our app window. Let's build the app and check if we've introduced any error. Looks like I've used the wrong names for the clear and present functions. Easy to fix it. Let's build and run the app. Now we have a window filled with the color we defined earlier. Before going further, let's do some house cleaning. I don't like the use of global variables, so let's gather this into a struct that will store our app state. We need to store our app state object on the heap in order to keep it alive once app init ends. So we use malloc to allocate space for it. SDL3 will let us hook our own app state to the void pointer called appState they predefined for us. This will be passed to all the other callbacks so we can access it if necessary. Next, let's initialize our appState struct. As you've probably noticed, after we've removed the global variables, we have some errors that need to be fixed by using the fields of the appState struct. Please note that in the appIterate callback, we need to convert the void pointer appState to the appState struct to let the compiler know what fields are available. That is because SDL3 passes to the function a void pointer on which we can't directly access the fields it points to. Finally, we can free our heap allocated app state in app quit. Since this was allocated by us, SDL won't free it for us. We are done with the house cleaning, no more global variables. Let's rebuild our app and check if everything works as expected. We are good. Next, let's actually draw something, like some points. We can add a fixed size array of points to our app state struct and the number points field. Because points is a fixed size array, we can use SDL array size to retrieve its number of elements and store it in number of points. Let's initialize our points array with positions on a circle. We could as well have used random positions to see some points drawn, but using a circle makes for a more interesting and useful example. As a quick reminder, we can calculate the x and y of a point on a circle using its parametric equations, where xc, yc is the circle center, r is the radius, and t is an angle in radians that goes from 0 to 2 times pi, or 0 to 360 degrees. Next, we can define a step by which we will divide the 0 to 2 times pi interval and use this step to calculate the value of the angle t. Let's also add the circle radius to our appstate struct and give it an initial value. In order to calculate the angle t, we'll loop from 0 to number of points, and at each step we'll have a new value for t. Using t, we can calculate the x and y. For now, let's ignore the circle center positions and assume it is centered at the origin. Once the points positions are initialized, we can use them in appiterate. For this, we'll first define a new draw color that is different from the background color we've previously defined. For simplicity, I will use black for the points. Next, we can actually draw the points using SDL render points. Let's run our program. Now we have something like a quarter of a circle at the top left corner of our window. In SDL, the origin is at the top left corner with x going from left to right and y going from top to bottom. If we want to see our full circle, we need to translate it to the right and down by some quantities. For simplicity, let's move the circle to the middle of our window. For this, we can define xc as half the window width and yc as half the window height. Let's rebuild our program and test it. As you can see, now we have the circle visible in the center of our window. Because we've used a small number of points, our circle looks a bit discontinuous. A simple fix is to use more points, say 500, and see how it looks. Much better. As a side note, typically you will want to draw small segments between the circle points instead of adding more points. One final touch. Let's check for errors when we initialize SDL and when we create the window and the renderer. Now, if for any reason there is an error, the code will log an error message and exit gracefully. Let's check if our last change introduced any bugs. Looks fine. Thanks for watching, and please like, share and subscribe. If you are interested in other programming subjects, please let me know in the comments.